So, have you ever just stopped and looked at a PowerPoint in your kitchen, or maybe a light fitting up in your ceiling, and wondered, how on earth do we stop these everyday appliances from just burning our buildings to the ground? I mean, it's a serious question. Electricity is this massively powerful force, and without some incredibly strict rules, it's basically a disaster waiting to happen. Well, today, in this explainer, we're unpacking what is essentially our ultimate invisible shield against thermal and electrical disasters. We're talking about Section 4 of the wiring rules, specifically the safe selection and installation of electrical equipment. All right, we're going to take what I like to call a blueprint tour through a typical property. Our goal here is to pull these strict compliance mandates right out of the dense, heavy rulebook and bring them into practical, everyday focus. Think of it like putting on X-ray glasses to see the hidden safety nets built into your walls, your ceilings, and even your backyard. Okay, let's dive right into this. So here is the roadmap for our walkthrough. First up, we'll look at shielding from thermal effects. Second, the rules for socket outlets. Third, safe recess lighting installation. Fourth, we'll cover kitchen and heating appliances. And finally, we'll step outside to look at outdoor hazards and gas equipment. Okay, let's jump straight into part one, shielding from thermal effects. The golden rule here is simple, but it is absolute. Electrical equipment must not cause fires or burns under normal load. I mean, sounds obvious, right? But when you look at the actual hard data for maximum temperature limits on parts you can reach, there's this fascinating contrast. For a handheld part, say a handle you literally have to grip to operate, the maximum limit for a metallic part is capped at a super strict 55 degrees Celsius. But if that same part is non-metallic, the limit bumps up to 65 degrees, and for parts you might touch but don't necessarily hold, it jumps to 70 degrees for metal and 80 for non-metal. It's a brilliant real-world application, right? The standard is actually factoring in how different materials conduct heat to make sure we don't end up with severe burns. Moving right along to part two, rules for socket outlets. Now, before we actually look at the sockets themselves, we kind of need to clear up some industry jargon that frankly trips up a lot of installers. Basically, what happens at the exact point where a building's wiring meets a piece of equipment? Well, we have what's called an installation coupler. This is a connecting device meant for permanent connection, and crucially, it is deliberately not meant to be plugged or unplugged while under load. It's really just part of the building's fixed wiring system. On the flip side of that, you have equipment wiring, which is all the internal wiring actually inside an appliance. Drawing a hard line between the two is absolutely critical, because the installation wiring has to follow the strict standard we're discussing, whereas the equipment wiring follows its own specific manufacturing standards.
All right, now for a rapid-fire spec. The baseline rule we all know is that every socket needs a switch, right? But there are actually exceptions. If a socket is put in for one very specific appliance, it's not accessible for general everyday use, and it's located more than 2.5 meters up off the floor. Well, in that highly specific case, its remote switch doesn't actually require the standard rigorous labeling. Just picture a socket way up near the ceiling for an exhaust fan. Because it's totally out of the way of normal human interaction, the standard eases up on the labeling requirements just a bit. And speaking of practical exceptions, you really see how the standard allows for real-world flexibility here. You don't always need a rigid one-to-one ratio of sockets to switches. Actually, a single switch can legally control two sockets, provided they are sitting right next to each other. Plus, and this is a big one, a standard 10-amp socket installed for a fixed appliance that isn't readily accessible, like, say, the one hidden all the way behind your built-in dishwasher, it doesn't even need a switch at all. It just goes to show how the rules bend for everyday practicality without ever compromising the overall safety of the system.
Let's move on to Section 3, Safe Recessed Lighting Installation.
Let's mentally move up into the ceiling space now. Honestly, this is a massive high-risk zone. Recessed lighting interacting with building insulation has historically caused some truly devastating house fires. Because of that, understanding luminaire classifications is crucial. These labels dictate exactly how a light fitting can safely interact with insulation. For instance, non-IC means insulation absolutely cannot touch it, and just so you know, these are strictly forbidden in residential setups here. Next, you've got do not cover, which means exactly what it says and requires strict physical barriers. Then there's CA90, meaning flammable stuff can touch the sides, but definitely cannot go over the top. And finally, IC or IC4 means the fitting is fully designed to be safely buried under building insulation. Getting these classifications mixed up is exactly how roof spaces catch fire, which is why these rules are so rigid. And because the stakes are literally a house fire, the standard mandates a highly visible warning sign in any accessible roof space. It clearly states, "Warning, recessed lights have been installed in this roof space. To reduce the risk of fire, do not cover the light fittings with thermal insulation or any other material unless in accordance with instructions." You get the idea. That right there is a life-saving responsibility placed squarely on the shoulders of the installer. It ensures that if an insulation contractor or a homeowner crawls up into that roof 5 years later, they know exactly what hidden dangers they're dealing with.
Stepping back down, we hit Section 4, Kitchen and Heating Appliances.
So back in the kitchen, there is a magic compliance number you absolutely have to know. 150. That's 150 millimeters. This is the strict, prohibited location zone for any sockets or switches extending outward from the edge of an open cooking surface, like your gas or electric cooktop. And I mean, the why here is pretty obvious, right? We simply cannot have electrical cords dangling directly over open flames, and we definitely can't have switches getting coated in boiling grease or catching fire. It is a 150 millimeter buffer of pure safety. Now, what about heating? Well, for room heaters, the standard makes this really brilliant distinction between two types of control switches: isolating switches and functional switches. An isolating switch is entirely about maintenance safety. It has to be installed either near the room's entrance or all the way back at the switchboard, and it lets a tradesperson completely kill the power before they open the heater up. A functional switch, though, that's just for you and me, the everyday user. It just needs to be in a highly accessible spot in the same room so you can turn the heat on or off. So it's two different switches achieving two completely different safety goals.
And they take this whole maintenance safety concept to the absolute extreme when it comes to water heaters. The rules dictate that any fixed wired water heater must have an independent, lockable isolating switch installed right next to it. But here's the kicker. It cannot be mounted on the unit itself. It builds right on what we were just talking about. If a plumber is out there draining a tank, they can physically padlock that switch in the off position. It guarantees that someone inside the house can't just accidentally flip the breaker back on and deliver a fatal shock to the person working outside. It's foolproof.
Finally, let's head outside for Section 5, Outdoor Hazards and Gas Equipment. Out here, the actual architecture of the building dictates your electrical hardware. Basically, if you're installing electrical accessories outside the protective shadow of a roof overhang, and they precisely define that shadow as a 30-degree angle from the edge of the roof, those accessories must carry a minimum ingress protection rating of IP33. Put simply, anything sitting outside that 30-degree protective bubble is officially exposed to the elements and needs serious shielding against rain and moisture. But hey, rain isn't the only outdoor hazard we have to worry about, right? We also have to think about gas. The standard very explicitly links electrical safety with gas equipment. Around outdoor gas cylinders, they mandate these strict exclusion zones where any electrical equipment that could spark and act as an ignition source is just flat out prohibited. No sockets, no switches, no lights, period. This applies to exchange and fill cylinders for heavier than air gases. A single tiny spark from flicking a switch near a leaking cylinder, yeah, that's all it takes to cause a massive explosion.
And that actually brings us to the end of our tour. But I want to leave you with this final, frankly, kind of chilling reminder specifically regarding capacitors. It states, warning, ensure that capacitors are completely discharged before working on equipment. It's such a powerful summary of everything we've talked about today, because even after you've flipped the switch, after you've locked out the isolator, and you are totally sure you've turned off the power, massive amounts of energy can still be stored, just waiting there in the dark. It just goes to show how thoroughly Section 4 tries to protect us at every single turn. But it also kind of leaves you wondering, doesn't it? If stored energy can linger long after the power is cut, what other invisible dangers are hiding in the walls right beside you?